For shear strength, we turn to section 22.5 and start with our equation for nominal shear strength, Vn equals Vc plus Vs, the sum of the concrete and the steel shear strength contributions. The code reads that shear reinforcement is required wherever Vu is greater than or equal to 0.5 phi Vc. So we'll first calculate Vc to check this condition. From equation 22.5.5.1, Vc is 2 lambda square root of f prime c Bw times d. We'll take the variables in English customary units. Because of the square root, we always need to take the variable, the f prime c value as psi. We'll convert to metric later. So lambda equals 1.0 for normal weight concrete. And from before, we have f prime c is 1500 psi. Bw is the web thickness taken as W effective of the anchor of 42.8 inches, and D is our distance from the top of the section to the centroid of the tension steel at the bottom, and this is going to be 25 inches in an A2 anchor. These dimensions are read straight off the A2 anchor detail. And when we put all these values together, we get around 369 kilonewtons for our value of Vc. And you will find that reinforcement is likely almost always required. So we will add our Vs term in. And we'll calculate the capacity of the steel as well. Equation 22.5.10.5.3 gives us Vs equals to AV Fyt times d over S, where AV is our area of shear reinforcement in the shear failure plane. The section here shows an example of a crack and how this passes through our number 4 bar twice. So we get AV equals 2 times the area of our number 4 bar, or whatever size bar we're using as a stirrup. In this case, for A2 anchor, it's number 4. Fyt is the reinforcement yield stress of the tension steel, has 40 ksi. D is our distance to the reinforcing, and S, a new variable, is the spacing of our stirrups, which the drawings call out as 30 centimeters or 11.8 inches. Now we can calculate our Vs, which gives us around 151 kilonewtons, and combine that with Vc to get a 520 kilonewton value of nominal shear strength. We combine that with our strength reduction factor phi of 0.75, and we get a design shear capacity of 390 kilonewtons. We would then compare this to our ultimate shear to see if the section is adequate.